Okay, good evening to everybody on the West Coast. Got it here. They're Cal Poly. I'm Ria. My call sign is N2RJ. And this is my 25th year in amateur radio. Hard to believe. I started in high school, I want to say, and then, it's just stayed with me ever since. So tonight I'm going to present to you software-defined radios and a little bit about me. I like I said, I've been licensed since the 1990s, and I've always liked various types of technology in ham radio. I got involved for the tech and home brewing and such like that. I went to Brooklyn Polytech, so that's my school, and I did a double E, BSEE, and also I've been very involved in the amateur radio community. I am a director for ARRL, the National Association, and we like college and university ham radio clubs, and we also like scholarships. We have some big scholarships coming up. So if you guys need money for college, don't we have a scholarship open every year. So without further ado, and I like, my favorite activities are homebrew, kit building. I'm building a kit right now on my YouTube channel. You can see it. And I also like contests. I like DX. I like to generally, play around. Okay. So I am a Flex Radio user. A lot of this is going to be about Flex Radio, but I have other radio manufacturers in there as well. And I'm trying to keep it as broad as possible, but I relay my own experiences. Nobody's paying me to say anything here. Just thought I'd get it clear. So let me tell you a little bit about why I like DXing. I've ever since we I got started off in shortwave radio, and we would kind of listen to the BBC, Voice of America, because I grew up in Trinidad and Tobago, which is in the Caribbean, right? So that I'm from there. I'm sure you guys have students from Trinidad and Tobago there. And I learned a lot about, operating. I learned a lot about propagation, how radio waves propagate. And I also learned about the world, because you get a real education in geography when you DX, when you're a DXer. So other things I do some emergency communications. I used to be involved in New York City. I'm in northern New Jersey, by the way. So, and like I said, I like kits. I also do drones. I have my Part 107 from the FAA, so I do some drone stuff. I do YouTube. I do contesting. I like rag shoes. So let's talk about the architecture of a software-defined radio. And we're going to talk about two radios. We're going to talk about the Flex. The Flex 6500, 6700 are similar. And I'm also going to talk about the ICOM 7610 and how they've implemented software-defined radio. So here you have a high-level block diagram, right? And I'm going to annotate some of this here. So you start off here at the antennas, right? You have they draw 5 antennas here. I'm not sure why, but they usually have two antennas, and then they have a bunch of antennas that are for receiving only. So if you're a ham radio operator and you operate on the HF bands, which is the short waves that are used for long distance communication, you operate particularly on the lower bands, like for example, 80 meters, 160 meters, you're going to want separate receive antennas. So they have separate receive antenna connections here as well, right? And this here, basically antenna matrix is like an antenna switch. So they have a switch in front there. Now they have something called, they call, this is a proprietary term, it's called SCU, spectral capture unit, right? So this thing here. And within the spectral capture unit, you have front end filtering. So you have filtering, basically analog filters, you know, crystal filter, not crystal filters, analog filters with like toroids and stuff like that. And then you have that basically filtering out some of the stronger signals that are out of band. Now that is switched in and out depending on which bands you operate on. Then you have a preamplifier and attenuator circuit. So that basically adds up to, I think, 40 decibels, 40 dB of gain, or you could knock it down by, I believe you could knock it down by 20 dB of attenuation. Then you get into the real interesting part. You have an analog to digital converter, right? And you notice you have two of them, okay? And this would be like in a radio with two independent receivers. So you have two of them here. This goes into a digital signal processor unit, which is the Vertex 6, which we're going to show just now. And it's FPGA. So they basically program in some custom code into this Vertex 6, which they use as a DSP. That goes into Texas Instruments DaVinci, which is their DSP, and then digital signal processing and control. And then that goes out to the audio digital signal processing, which would be things like equalizer and stuff like that. And then it goes out to your speaker and mic, okay? And all of this interfaces to the world, I want to say your computer via Ethernet. So you have an RJ45 at the back, and this connects to your computer via your home LAN or even Wi-Fi. Now that's the receive chain, right? The receive side. So you have two of these on the receive side. On the transmit side, you have an automatic antenna tuner, right? Basically, you switch relays, you switch inductors and capacitors. You have here a transmit filter to filter out some of the spurious emissions and harmonics from a signal. Yeah, I'm going backwards. You have a 100-watt power amplifier before that, and then you have a digital to analog converter. But you notice this is also tied into the FPGA and the DSP. And of course, all of this, you have either temperature controlled, crystal oscillator, oven controlled, or GPS disciplined oscillator. And that goes to the master clock. And then that goes up to discipline all these here, right? And of course, you have some other things. You have the power system, basically, you know, the power supply built into the radio, not from AC, but DC. You have a supervisor. The supervisor basically is a system on a chip, right? And then that runs Linux, okay? And then they have a little display in front, okay? All right, so that's everything in a nutshell in terms of the architecture of the radio, right? This is the Flex 6700, and we'll move on to the next radio, which is a...
I don't know if Jack had a quick question there.
Sure.
Is there any reason why they put the digital to analog conversion before or they put the filters after the amplifier and not after the transmit amplifier and not in front of it?
Yeah, because basically, you know, oops, sorry. Because what happens is that you definitely want to filter out some of the you know, because generally amplifiers are supposed to operate linearly, right? So they're supposed to be linear devices, but in reality, they're not. And what happens is when you pass the signal to the amplifier, it will have, you know, unwanted components like spurious emissions and harmonics and all that stuff. So you really just want to filter that out before it reaches out to your antennas. Okay. So this is why they place it as far down the chain as possible, because really from the digital to analog converter, the signal is more or less perfect. Once you hit this analog amplifier, I'm drawing to myself here. Yeah, once, oh, come on, Zoom behave. Hang on. Okay. All right. Okay, let me take off that here. right? Yeah. So once you hit this analog amplifier here, you're going to generate harmonics and other crud in here, right? And you want that to go out, you know, and filter it here. So this will take out the stuff and then goes out to your antenna tuner, the matching network, and then goes to the antennas. Like I said, out of here, it's more or less perfect, right? And it's very low level signal. So there's not going to be much, you know, and then once you amplify that, you take that out. Okay. All right. Let's see here. Clear all drawings. Next. Okay. Yeah. So they have the, you know, this is like a view of the boards you have here. Yeah, you have the Xilinx Vertex 6 FPGA. You have here the digital to analog converter, which is a transmitter. And then I believe these two are the analog to digital converters, right? And they have a number of other stuff. The radio, actually, the hardware is, you know, it might seem sophisticated, but the real magic happens in the software. So the hardware, you know, I've looked inside this radio. I've been really inside this radio, and I've been inside like a conventional transceiver. The conventional transceiver is more complicated from the hardware front. Okay, so they have the two main chips. The you know, you have the TI DSP, and then you have the Xilinx Vertex 6. So now this is another this is another commercial SDR. This is the ICOM 7610. Right? They more or less operate the same way. This is a block diagram I got from them. They have the antenna network matrix here. They have something called Digicell, which I believe is, might be their filters. Oh no, this is something else actually. Then they have the bandpass filters, right? And then they have the analog to digital and goes to the FPGA, which is their DSP and such like that. And they have digital to analog and then audio amplifier. Okay. And they have two independent receivers as well. But of course, in each one of these radios, well, ICOM decided that they're only going to have two receivers. Flex decided that with two hardware components, two hardware receivers, two spectral capture units, they're going to be able to divide that up virtually into as many as 8 virtual slice receivers. Okay. All right. Oops, what's happening here?
Question here.
Yes.
So how much signal processing is done on the FPGAs versus the dedicated DSP chips? And why would you have DSP chips dedicated when you can just put it on an FPGA?
So basically, I believe it came down to economy of scale and, you know, how much it costs really. I believe most of the stuff happens in so it's in stages, right? They have with the Flex, let me see this here. They actually do more, I believe they actually do more processing in the second chip, which is the Texas Instruments digital signal processing chip. See if I can bring up back that slide here. Rather than the this one. Rather than the Da Vinci, right? So the Da Vinci is a pretty powerful processor. They actually use it in like processing video and such like that. But I believe they rely more heavily on that versus the FPGA. This is basically based on my conversation with them. I could be wrong, but that's basically what I understood. And as for why, but they do actually have a fair amount of flexibility in the FPGA to write custom code and such like that and improve like the algorithm and improve some of the, the processing and such within the FPGA, whereas they're more limited within the Da Vinci. Okay. All right. Okay. So, we're talking about these radios. I gave you a whole technical overview of what these radios are and their architecture. And now we come to see how various manufacturers are kind of implementing them. You know, SDR used to be a very niche product where you'd have like the cutting edge people would have SDRs in their shacks, and they basically have very primitive SDRs actually, which were called quadrature sampling. So what they did was they actually took the signals out of the air, and then they mixed that down to baseband, and then you would have an in phase and a quadrature signal, IQ signals, and you put that in a PC sound card, and you would then have software that would process it, and then, you know, that was your radio, right? No more. Almost everybody has now moved to direct sampling. So you have a bunch of different manufacturers doing that. Of course, Flex has been the kind of like the hallmark of SDR. They've really been like the boutique SDR manufacturer. Apache Labs is an OEM. They actually made transceivers, but they had there's an open source project called HPSDR, High Performance Software Defined Radio. And then they used to be like a collection of different boards, you know, each module on different board. And eventually they kind of reduced that down into one board. I believe they call it, might be Hercules. But long story short is they took that project and they commercially manufactured it. So they have another thing. The difference between Flex and Apache Labs is that Flex does most of the processing within the radio, right? So like I mentioned, they have that whole supervisor and control. They run Linux in the radio. And then what they would do is with all the processing, they would then present streams of various, you know, decoded or even a wideband stream to the host computer or other device. So for example, what they would do for audio is they would present audio streams, right? When you're on the local LAN, it's basically PCM. And when you are remotely, they actually use Opus and they compress it. So there is a little more latency when you're remote versus local, which actually is partially because of network delays and also because of the compression that they apply. And then Flex also sends little tiles, pan adapter tiles. So the little screen here you see here, right, is actually reconstructed from image tiles that they have here, little blocks. And then they have this here also being sent out. They also send telemetry, like metering and such like that. So the signal levels and other stuff, and they take control signals. And all of this is actually via an open API. So if you ask Flex, they will send you a copy of the API. They even publish it on their website. But I think they keep the latest ones. It's just that they're always improving things. So they have the latest API that the developers have, and they'll send it to you. But on the website, they have it too. Apache Labs uses thick clients. So Apache Labs, they do some digital signal processing within the radio, but they send a fat stream of data over to the client software. Now, what I understand is that later versions, they kind of have a thin client, and you can use thin clients and basically use it similar to how you'd use a Flex, but they've always been a thick client. The ICOM radios here, this is the ICOM 7300. I'm sure most of you have heard of this radio. This is a $1,000 radio, which is kind of actually pretty good for an SDR. They have basically just taken the traditional radio interface, the knobs and everything, and just put it in, you know, to a radio. So people will see this and they'll say, yeah, we know it's an SDR, but you know what? It's it just behaves like any other radio. Elecraft is getting into the game. So Elecraft is a Californian company. They make these, the K4, which is their direct sampling SDR. They're now shipping these. Then Yaesu, which is a Japanese company, they actually make the FTDX 101 and they make the FTDX10, which are SDR receivers, and they're actually pretty good performers. And we're going to talk about performance. So everybody's doing SDR primarily because it's no longer a boutique thing. It's in the mainstream, and the benefits are immense. And more importantly, the prices of the hardware, and particularly the computing power required to run an SDR, have come down. You know, they said that we're going to actually reach the end of Moore's law soon, maybe. But you know, things have gotten so cheap that they could build a radio for previously what was a very expensive and impossible proposition. Okay. So not to be forgotten is that they have, you know, the lower cost radios from China are now making their way here. This is a Xiegu X6100. They're made in China. They're actually Linux based. It's kind of interesting. If you go on YouTube and look for temporarily offline, he has all sorts of videos where he rooted the Linux in this, and he's able to get a command line and enable Bluetooth and Wi-Fi and such on it, and really cool stuff. But this is a portable radio with a built-in battery, so you could take this backpacking, you could take this for parks on the air, summits on the air. It's 10 watts and 5 watts, so it's QRP. This is another one made by a Russian company. This is a Lab599 Discovery. This is actually, it's an SDR, but it's more designed to be a rugged portable radio. So what happens is that you are going to put this in your backpack, climb up a mountain, or, you know, and you're going to use this, and you could throw this on a rock and nothing will happen. It might get a few scratches, but, you know, this has an all aluminum case. It has aviation style connectors, and it's just designed to be rugged, right? You look at Julian, OH8STN on YouTube. He has a review of this radio. He loves this radio because that's his kind of thing. He loves survivalist type of communications. And, you know, this radio is up to the task. It doesn't have the bells and whistles of the others, but there. So from an end user standpoint, right, we did the architecture. So let's talk about the practicality. What does an SDR offer you? So they offer you plenty of visibility and spectrum. You know, when I first got my hands on an SDR, I'm talking about the soft rocks, I was amazed to see so much stuff on the band, you know. And then performance, the best performing radios are typically SDRs, even like, you know, the cheap little SDRs, the RTLSDR or whatever, they outperform a lot of legacy radios. Integration, so it's a lot easier to program in a software functionality and expose an API over Ethernet, or expose, you know, even like a virtual COM port or a virtual sound card, which is actually done in software on a client. And you can actually integrate that with a lot of things. A lot of these software-defined radio people are now using NodeRed. So NodeRed, they write flows and modules and stuff for that, and they're able to control their station. They set up NodeRed on a Raspberry Pi, and they have a full web dashboard with NodeRed, okay? And of course, remote operation, I like to call it presence. So, you know, you're able to be at your radio wherever you are in the world. I like to operate from my iPhone. So, you know, they don't have an Android client yet, unfortunately. So this picture is a little dated, but this is a 160 meter contest. And you could see a whole band full of CW signals. I mean, you know, it's just amazing to see everything, whoops, that wall to wall. All right. It's like, keynote is terrible sometimes. But anyway, you see here, you know, you see all these signals, all these Morse code signals here, right? Going from 1.8 up to 1.87, right? And somewhere in 1.84, they have FT8. And I'm actually viewing two of them at the same time. Now, these additional displays here, I have my amplifier here. And I have, the other stuff. I have CW skimmer, which I'll talk about in a bit. Okay, so next. So now you can actually, so remember I told you basically that Flex exposes the API with streams and such like that, right? So they don't only stream audio. What they do is they can stream out a 192 kilohertz slice of spectrum in an IQ signal, right? So in phase and quadrature, stream that out, and then Windows software will pick that up and then surface that as a virtual sound card. So it'll take that stream over Ethernet and then present that as a sound card device. And then you can take a software like CW Skimmer, and then you can take the IQ input, and then it will decode things like Morse code. There's a RTLSDR skimmer to decode radio teletype. And you can do some really fancy stuff. You can even take a third-party software-defined radio client software, such as RTLSDR. You could feed that in, and you could monitor a lot of spectrum. You could record the whole thing for later playback. A lot of contest sponsors are recording whole entire swaths of spectrum to adjudicate and find people cheating. There is, I'm not sure if you're familiar with time difference of arrival, where Flex worked on a project where they would have multiple receivers that are GPS synchronized, and they're able to do direction finding, like really, accurate direction finding based on time difference of arrival. So if you've ever done fox hunting, you'll know that you have two antennas, and as you shift them, off of the fox, you'll eventually be able to pinpoint where the fox is. So think of this on a global scale. All right. Anyway, then you could take this data and, of course, feed it back into your radio and see stuff. Okay. With speech recognition technology going the way it is, maybe you'll be able to decode speech as well too. I don't know if we're there yet. I know there's a lot of natural language processing in all these smart speakers and stuff, and probably the NSA has a lot of stuff that they don't tell us about. But maybe somebody will develop a skimmer. There's always been a joke in the ham community that somebody's going to do this. Maybe somebody will take it seriously. And then, so this one was originally a video. Unfortunately, I can't get that video to play, but I have it on the YouTube channel as well. So you can actually take a look and see where I have the skimmer running. And then here I have this, okay, yeah, I have this, all these little things. This was the expedition in Africa somewhere. I believe it was either Annobon or Equatorial Guinea. And then I see all these callers up here, right? I see a lot of my friends actually, but you notice I see a little pink 599. So for those of you that operate DX, a lot of DX works split operation, right? Meaning that they transmit on one frequency, and then they would, when they're answering, they would tune across a wide range of frequencies, listen, pick out somebody, and then reply to them. What I do is I look for these 599s, which means they just answered somebody there, and I would place myself right below it, right? And then I would get in and out and call them and, have them in my log, lickety split. Okay. Let's talk about performance. So, in the analog world, you have a lot of analog factors to deal with. And of course, our world's electrically noisy, but you also have a lot of self-generated receiver noise. When signals are in the digital domain, they're more or less, to an extent, isolated from those external factors. So you'll find that the noise floor in an SDR is dramatically reduced. The dynamic range is a lot better. And of course, with the direct sampling SDRs, since they don't have a lot of mixers, because typically a super heterodyne, which is a traditional type of radio receiver, has several stages of mixers. They have the intermediate frequency, and they would in mix, and then they would introduce some phase noise there. With fewer mixers in an SDR, since they digitize it as close to the antenna as possible, you'll find that phase noise is drastically reduced. Sherwood, and I want to actually go to the Sherwood website and show you now. So let me bring this here, Sherwood Engineering, and I'll share this here. Let me, okay, new share. All right, I'll do here, okay. Yeah, so Sherwood, Rob Sherwood, he's an engineer and he's a ham. He lives in Colorado and he does like a whole bunch of receiver testing. So he basically would walk into HRO, ham radio outlet, and then he would, you know, he would basically just walk out with a radio and test it, right? Now he sorts these radios by what we call third order dynamic range narrow spaced. So what basically how he tests this is that he injects two signals that are spaced together closely, right? One of them high, high amplitude and one of them low amplitude. And then what happens is basically he would try to find the point at which the difference of them in dB is where you can't hear one, right? Where you can't hear the weaker one. So he ranks these radios by that. And the practical application for DXers and contesters is that you're able to use this radio in a very crowded band, because usually in a contest, especially like, an international contest, you'll have all these signals jam-packed close together. And then what happens is you're unable to separate them, right? Because you have this person like really, really powerful. And then you go next to them, there's a little tiny signal there you're trying to hear, but then your receiver is basically overwhelmed and it reduces its gain, or it might, worse yet, it might pump the gain, right? It pumps the AGC, the automatic gain control, and then you're unable to hear that. So the SDRs actually have, if you look at this here, they tell you, they give you factors like the noise floor, okay? You have the noise floor minus 127 dB. I think the natural noise floor is about minus 110. So, this is crazy. Dynamic range wide space. So this wide space is 20 kilohertz, I believe. And narrow space is 2 kilohertz, is 110. And this is on the Yaesu FTDX 101D. You have Flex 6700. Flex used to be number one. You have 99 dB of wide space dynamic range and 108 dB of narrow space. And then you go down here, you see all these radios. Well, Elecraft has always had a high performance radio, even though it's a super heterodyne. But the Elecraft actually, K3, not the K4, the K3 is actually part SDR. You have this ICOM 7851, which is not an SDR. So you see, and this is an expensive radio. So, they drop further down in the rankings. God help you if you paid $16,000 for this Hilberling. And this Hilberling is a pure super heterodyne receiver. And, you can see how far down it is in the rankings compared to SDR. So the SDRs are basically, they're blowing all these old radios out the water. And I'll share it again here. Let's see here. Where's my keynote? Yeah. So, they're kind of like, they're really just, where'd it go? Oh, there we go. Okay. It's kind of confusing. Yeah. So, the top performance are SDRs, right? But there are always caveats, right? Okay. So if you have ever read like product reviews in QST, they confirm these results. They test these radios and they do some of the similar things. ARRL has its own metric called RMDR, which is reciprocal mixing dynamic range. So basically it's the ability to hear weak signals among adjacent strong ones. And you can see here, the numbers are very impressive. So a little bit about phase noise. As the third order dynamic ranges increase, phase noise, dynamic range, it's basically the range of phase noise. It becomes the dominant metric. The legacy, as I mentioned, the legacy receivers, they have to use frequency synthesizers, and then they have a lot of phase noise and spurious output, and it's kind of hard to keep that under control. Flex, they basically have a very low noise master oscillator, right? Which is either, temperature controlled, oven controlled, or GPS disciplined, operating at almost a gigahertz, 983 megahertz, right? So it's very cool stuff. So I'll be sending you PDFs of the slides, by the way, so you could read this in more depth.
Just to let you know, you're showing your whole screen, not just keynote, in case you didn't prefer that.
Okay, thank you. So you know what? I'm gonna actually cool. That's a good thing. Let's see here. Google Chrome Keynote. How's that?
Beautiful.
All right, thanks. Okay. So dynamic range, as you know, clipping, when you clip on digital signal, that's it. When you clip on analog signal, you have a little bit of wiggle room, right? Things might start to get nonlinear at the top. On a digital signal, that's it, you're done. So you got to watch out for that. A lot of these radios have analog front-end filters, like I mentioned, for that reason. Let's talk about integration, right? This is my shack. Well, this is one iteration of my shack. I have my radio, I have my amplifier. I have some cool challenge coins I got from ARRL for operating the Centennial event. And so to be quite honest, as we move away from legacy modes, well, a lot of people enjoy legacy modes, but a lot of people are taking up the data modes, the digital modes. And people want to integrate their shacks. So they have the software, their logging software, their Digimode software tightly integrated with the radio. And there's, like I mentioned, since the API in a Flex radio, and even, the ICOM radios are tightly, are basically open, a lot of people develop third-party software to increase automation. So why do you want to automate? Right? If you're chasing some rare DX, I'm a very competitive DXer, so I might get up early in the morning before the crack of dawn to see if I could see Japan on 160 meters, which I have worked. And it's hard from the East Coast, by the way. It might be a dime a dozen in California, but in the East Coast, it's rare. And I want to get in early because I want to make sure that I work them first before the horde descends. So if you have a well-integrated automated station, I just get on, or even use my phone. I get on my phone, I bring up my SDR client, and I'm in like Flynn, and then I'm gone. So less wiring. A lot of these radios now come with a USB connection, and it's just easier in an SDR because everything's already digital. You don't have to have additional components like a sound card. You don't need to have a USB to serial converter, none of that nonsense. What you do is they basically take everything digitally and then surface it on the USB port, as with the different profiles, and some of them have Bluetooth. My ICOM 705 has Bluetooth. It has Ethernet. It has Wi-Fi, and there's software from Mac where I can operate it, just like a Flex. Like I mentioned, Flex decided to go with Gigabit Ethernet, which might give them a little more versatility. And we're going to talk about that next. The world is your shack. That was a real nice tagline. So, I have a busy life. I go all over the place, but I still manage to work DX. How can this be? Well, here you are, if your radio is a computer, and your radio deals in data, and you can send this over the internet, right? And then you pick it up with a client software, and you're just you're good. there are actually services that offer this now, remote ham radio. They have a youth network now where they have, for young people, they give them free access to flex radio stations. So you can sign up and get on. I have other presentations on remote operation on my YouTube channel and other places. I have them in other places, but the point is that, again, you don't need the extra hardware when things are already digital. This here, I'm actually operating this from Buenos Aires, Argentina. And I was operating the ARRL DX phone contest. I have an iPad via Wi-Fi, unreliable Wi-Fi, but it's Wi-Fi nonetheless. And I'm there connected to my radio in New Jersey. And I have my computer connected also to the radio client software. And I'm good. And yeah, I'm running Windows on that old MacBook, but who cares? So more tools of the trade. Oh yeah, you ever mod a Raspberry Pi and put an antenna on it? I did that. CW Skimmer, I mentioned, allows you to decode wide swaths of Morse code. I talked about that already. Whisper for propagation analysis. So a tip I got from Tim Duffy, K3LR, is that he runs a Whisper on his antennas a week before every contest. And he gets to learn something. He gets to learn when the band opens and closes at his location. So he has an instant readout of his propagation conditions. Excuse me. I believe he uses a solution called Soda Beams. I forgot the name of the product. You can also kind of do that with PSK Reporter. You leave your WSJT software running, and then you could go on pskreporter.info and then see all where you received. So let's talk about what you can get for $1, right? Because, inflation and all of that stuff. You can't get anything for $1, unfortunately. You can get a functional SDR receiver for $21, although this is not really an SDR. This is the SoftRock, which is the older SDR kits. They need a PC sound card. They're a great way to get your feet wet, but they're kits. There is also RTLSDR. So I'm sure you know about RTLSDR, where some Europeans figured out that a particular TV tuner chip worked as an SDR. And what they have is they have the RTLSDR inside of the SDR, and they have a converter that converts from HF
you can just hold
to
it.
VHF.
I'm not going to be able to watch it anyway because driving. That's true. Like, place it with the sound. Yeah, here or something. In the middle.
What happened? Oh, did some die?
Not yet.
It looks like they're having internet troubles. So.
Oh no. Okay.
Zach and Matthew, you can hear this.
Okay.
Okay, fantastic. Thank you. Sorry about that.
We're almost done anyway. I think we just have like 3 more slides and then we're done. 5 more slides.
Oh, I think we're good to go again. They were just
All right. Can we go on or?
Yeah, I think they were just unmuted and they were trying to do something.
Okay. All right.
Yeah, sorry about that.
Yeah, no problem. So anyway, RTLSDR, it's a great way to get your feet wet. You can buy either a commercial thing like this, or you can buy like the DIY kits. They probably sell them like AliExpress or whatever, or Wish or whatever, one of these Chinese sites. Or you could buy them on, I think like some of the major ham vendors have them too. If you operate Morse code, admittedly, a lot of presentations I gave people, they operate Morse code, but from what I understand, you guys operate mostly voice. But if you do operate Morse code, and if you want to learn Morse code, the Long Island CW Club will teach you. And there's a great renaissance in Morse code. So it's a fun mode to use. You could send a few CQs out and then go to reversebeacon.net. And a network of SDRs will receive and then aggregate this data. And you're able to see here, like in real time, where you're getting out. Then you're into, now you can actually use reversebeacon.net to actually, over a contest weekend or a long period of operating, you can actually compare stations that, based on their signal strength. I went up, I compared K1ZZ and K3WW against me. And, in some respects, we're kind of neck and neck, in terms of like signal strength. Well, there are some rules with this. There are some people that say, well, if you're in a DXing program like the ARRL, DXCC, and such like that, there are some stipulations like you can't use remote receivers, but you can use a remote station where everything is in one area. Eventually, I think the rules are evolving. I mean, they just passed a rule that allowed live streaming of contests. So eventually they're getting there. We're trying to get them, in touch with some of the more modern stuff. So, I always plug ARRL membership. If you're not a member, they have rates for college students as well too. And, but if you are a member, thank you. And, we always provide good stuff. All right. But even if you're not a member, we have a lot of free things available, a lot of resources. We have, and we have, of course, we have like, the scholarship program and such like that too, through the ARRL Foundation. And this is my YouTube channel. You can go and see a lot of my videos. I think I just crossed 10,000 subscribers tonight, if I'm not mistaken. Probably, I don't know. I've been watching it like a hawk. Nah, I haven't crossed yet. I'm like literally at 9,999. So anyway, that's it. I hope I haven't bored you to tears, but I really appreciate giving the talk.
Thank you very much. I think, it was really interesting to see the Flex stuff, because we're actually going to be purchasing a Flex here very shortly. Mm-hmm. And as part of some ARDC supported projects, and yeah, it's really cool to know how that works. I mean, I didn't even know that there was a GPS discipline oscillator available for the Flex, so that might be something we have to look into.
So that becomes real useful when you're doing VHF and microwave using transverters and stuff like that. I have one in mind for that reason. But are you seeing this?
Oh yeah.
Okay. Audio is a little difficult on the Mac, but anyway, I'll cut off my audio if I don't. You're probably hearing this anyway. Yeah.
By the way, I've heard a lot of good things about Long Island CW. I've heard a couple people highly recommend it. We have a couple people who've been wanting to learn. I think we had a couple who graduated within the last few years, but we have a couple people who are interested, but it's just kind of hard to find the time to get started.
Yeah, they're great. They're a great bunch of folks there. So yeah, here you see. So anyway, this is my radio. I use a Mac, so I use the Mac client. In many respects, the Mac client is more advanced than the Windows one, but that's how it is. So if you guys, have any questions or anything, let me know. Or if you have to go, I totally understand. But it's my mailbox is always open. It's N2RJ at awrl.org, or you could use Ria at N2RJ.com. Either one's fine. And I'm glad to hear you guys are getting good stuff from ARDC. They're a great bunch of folks. So
I remember the first time I saw I think it was just like a waterfall display on the KX3 or whatever. I was like, whoa, that's cool. You can actually like visualize people talking on a radio. That's crazy. Like as Jack said, we have a couple of projects that we're doing those now.
this is the ICOM 705. This is a portable radio, right? I don't have an antenna connected though, but basically it's the same deal. Similar.
Yeah, like Jack said, we have a couple of projects. Well, one in particular. So I know that there's many people here, as well as who will be watching this, the recording later, who are gonna find this really helpful. So thank you again. Jack, you have a question?
Yeah, one last question from me. Have you ever had anyone tell you that using SDR is cheating? That it's not the old way?
Yeah, you know what? People say that. People, they say like in a contest, they try to tell you that using the band scope is cheating, which is ridiculous,
People say that around like OTTY too, like that you're not actually doing anything. It's the computer that's doing all the contacts for you.
Yeah, FT8. Okay.
FT8, that's what it's like. Thank you.
So the interesting thing about FT8 is that it was developed by Joe Taylor, right? K1JT, who discovered binary pulsars. And Joe actually used his knowledge he gained from his scientific research and in radio astronomy to develop some of the algorithms for FT8. But the core is actually written in not Ruby on Rails, not any modern language, not even C++. It's written in Fortran.
Yeah, I had to install a Fortran compiler to get FT8 working in the shack.
Yeah, it's crazy.
Why would
Joe's a good guy, though.
Well,
Good.
yeah, I was using SDR in one of our T hunts, and that felt like cheating.
I mean, you know what? The tools will have to evolve, and the rules will have to evolve to meet the tools. There's no way around it, really,
Yeah. And if new stuff is out, the kind of the paradigm and the perspective of, oh, that stuff is too good, we can't use it. That's kind of a toxic approach.
Yeah.
At a couple of the T-Uns, there's a bunch of people just with the tape measure Yagis with their little, with the Wuxons or the Balpegs or whatever. And then there's certain people with their laptops with the USB connected, with the full-on stuff going on.
Yeah, it's pretty cool stuff. They have one other thing that escapes me a moment, but the flex system, a lot of people like to say, well, it's really kind of like, it's not, and this term is like so outdated, boy in his radio, so there's a guy who always on the contest forum said, no, I'm strictly, I'm a boy in his radio. I'm like, okay, I'm not. I like to contest and I like to use the tools in tech, and I love tech. So, all right, well, if there are no more questions, it was great, presenting to you guys. And if you want to talk more about the NodeRed setup, I have a friend who does the NodeRed. So Dave, WO2X, I can tell him and he could come and talk to you guys.
Yeah, that'd be awesome. Thank you. That was really great, really good resource to be able to have. And can't think of anything else to say except for thank you.
All right, thank you.
Yeah, thanks.
73, everybody.
See you. Yeah, thanks.
All right, good night.
Bye. And before I stop the recording, don't forget, what we got tomorrow, HR Fridays, if you're watching this on the same Thursday. What am I doing? Reach out to us or Ria if you have any questions.
Time and complete.
Next week, oh my goodness, that sounds fantastic. Next Thursday, we have our tours of the repeater and of the bunker. So sign up for that. And then after that, we have our search and rescue exercise. The announcement isn't out for that yet because I haven't figured out where the heck it's going to be. But stay tuned.
Yeah, and also we have a project work day this Sunday, 10 a.m. If you're able to come out, the more what we want to do is going to be dependent on the number of people that show up, and us moving some equipment is the impediment to getting all the RMRSR projects done. So if you're hearing this before Sunday, come on.
Beautiful. And yeah, make sure to let us know if you have any questions, email, Discord. Don't hesitate to email Ria too if you have any questions. She's happy to have anybody reach out. But yeah, thank you all for watching. Good night, good luck, and happy birthday.